Okay, so we talked about confidence intervals. Let's pull this off. We are going to use StatCrunch, but you still have to understand the concept that goes with it, right? So, in the Parent Teen Cell Phone Survey conducted by Princeton Survey Research Associates International, 800 randomly sampled 16 to 17-year-olds living in the U.S. were asked whether they have ever used their cell phone to text while driving. How many of us was that, right? Of the 800 teenagers surveyed, 272 indicated that they text while driving. I think the real question is was their parents sitting there? How truthful this answer was, right? Then we talk about bias. Okay. Anyway, of the 800 teenagers surveyed, 272 indicated that they do text while driving. Our job is to obtain a 95% confidence interval for the proportion that we're looking for there. Okay. Now, does it say anywhere in here that this is normally distributed? No. So let's kick back here a couple of pages real quick. Remember this? This is how we determine if it's normal. We have this formula to use, and we have to make sure our population is less than 5%. I'm going to scoot this over here. Is that not also the exact same case that was right here? I'm just making connections. I just want you to see what's happening with that. So it must happen first. You have to set this criteria first. If this criteria doesn't work, you cannot make a confidence interval. All right? So you have to set that criteria up first, and that's what we're going to do. Okay, so the very first thing we're going to look at, because we have to determine if it's normal, let's come up with what p hat is here, because we have to plug that into our formula, right, for normalcy. So this is x, and this is n. So we have 272 divided by 800. So what is 272 divided by 800? What do you get? 2 decimal places is good. 0.34, I get that also. All right, that's our p hat. So then step 2, I have to determine if this is normal. So in p, and it's p hat, right? 1 minus p hat has to be greater than or equal to 10. So 800 times 0.34, 1 minus 0.34 has to be greater than or equal to 10. Okay, plug all that into your handy dandy calculator. What do you get? Yeah, I get 179.5. Is that greater than or equal to 10? Yes. Criteria number 1, check. So there's our first criteria. Let's look at our second criteria. Oh, I've got too many numbers here. Let's call this A. Oops. Criteria A. Here's criteria B, is that N is less than 5% of the population. Is 800 less than 5% of all 16 and 17-year-olds? 5% all 16 to 17-year-old in the U.S.? Yes, and that's a judgment call, right? I mean, that's a pretty obvious judgment call. If it's really close and we need to know what that population is, then we can work with it, but we're good, right? I mean, we realize that that's going to be less, so we're good with that. All right, now here's where we go to StatCrunch. So we want to be 95% confident. In StatCrunch, so I'm going to scoot this over so we can see this. We are talking about a proportion. We always go to stat. That's everything that we do in this particular class, we go to stat. Now, because we're talking about proportion stats and with one sample, if you have a whole pile of data that you pull in and it's in this list, then you go with data. We don't have that. We are told 272 out of 800, so that's a summary. So proportion stats, one sample, and then either with data or summary, whatever your problem's given. Our problem right now is with summary because I'm told the information. If we actually had all of these 800 pieces of information, that would be with data because then you could see that data and it would work with that. But we're just given the totals. Does that make sense? So stat, proportion, because that's what we're talking about, with summary. And then it says the number of successes versus observations. So our number of successes were 272. Our number of observations are 800. And then we're not doing a hypothesis test yet. Oh, that's coming. That's coming. You'll be so excited. Not in this section, but here. Now, the standard walled is always the method that we're going to use, so don't change that. All right. And this is 95% confidence, so that's already set up for us because that's our confidence level. Then we click compute, and there is our information. Also, look at what else we are given. Here is the sample proportion. This is our p hat at 0.34. Yup, we've got that. 272 out of 800. Yup, we've got that. Here's our standard error that we're looking at. And then here is the lower limit and the upper limit. All right, our lower limit and our upper limit. So don't worry about the standard error. I said that because it just happened to be there, but we're not really messing with it. That is not our margin of error. That's different. Okay, but our lower limit and our upper limit. So I don't know, 3 decimal places. Let's go with that. So our lower limit is, and I'm writing this over here. Maybe I'll put it down below, see if I can. Nope, I can't. So great job. I'm going to put it down below here, see if you can see it on my thing. The lower limit is 0.307. And the upper limit is 0.373. Okay, so in StatCrunch, I want to write our steps out here just so that we can make sure we're good with it. So let me pull this up here, StatCrunch. We're going to do, whoops, let's do this. Stat, proportion, stat, and then one sample. From one sample, you have 2 options, just depending on what you're getting. It's either with data or summary. We did summary on this one. You can do with data, but those are your steps, all right? Okay, so I just wanted to make sure that we didn't lose those. All right, here's our upper limit and our lower limit. Now look at what's happening here. This is what I want you to get, all right? This is what I want you to get out of this. We have our point estimate. Then my upper limit is 0.373. My lower limit is 0.307, right? That is how I get to those different values. If I'm getting to those different values, I need to figure out what is my margin of error. So what is that margin of error? How do I get from here to here? Yeah, you could totally just subtract that, right? And what do you actually get? 0.033. And that is my margin of error. I'm going to add to get to the big one. I'm going to subtract to get to the lower bound, the small one. But this is what I really want you to grab a hold of. So from 0.307 to 0.373, we are 95% confident that the proportion of 16 to 17-year-olds who text while driving is between those 2 values. So let's write out our statement, because remember we said we're always going to write that statement out. So we are 95% confident that the proportion of 16 to 17-year-olds who text while driving is between 0.307 and 0.373. Because remember, this is based on a statistic. I'm going to make this 3 a little bit nicer. Make this 307. We'll just do the whole thing. This is based on a statistic, and now I'm saying, based on my statistic, I am saying the parameter, based on the population, is between these 2 values. All right, so we're giving ourselves that 95% confidence with that cushion associated with that. All right, now look at this part B. It kind of keeps up with what it is that we're doing. For the problem of estimating the proportion of 16 to 17-year-old teenagers who text while driving, determine the effect on the margin of error by increasing the level of confidence from 95 to 99. Now, do I have to go through and make sure this is normal again? No, we literally just did that. So we don't have to do that extra work because we're talking about the exact same problem. Do we have to figure out our point estimate again? No, we just did that. This is the same problem. So our point estimate is exactly the same, right? We know that X here is still 272. I already forgot. I got to look at it. See? Yeah, 274, and N is 800. X is 272, N is equal to 800. But here's the deal. We know the 95%, and we know our margin of error because we figured it out for 95%, right? Here's our margin of error at 95%. So 95% has a margin of error of 0.033. Now we have to figure out what is the 99% margin of error and how does that affect us? Well, we go back to StatCrunch. And instead of doing a confidence interval for 95%, we're going to do a confidence interval. Remember, proportion stats, because we're talking about proportion. One sample, again with the summary. And you will have to put it back in again if you get out of it. So you'll have to do that. 272, 800. And this time I want 99% confidence. So my margin of error here is based on this still 0.3, pardon me, 0.34. I have a lower limit and an upper limit. All right. So let's write that down here. So at 99% confidence, I'm going from 0.297 to 0.383. So this is 0.297. My point estimate is still 0.34 up to 0.383. How do I figure out the margin of error that goes with that? How do you get that? Yeah, oops, sorry. I didn't realize that was over the top. My bad. My mouse made it do weird things. Well, I can just scoot this over for crying out loud in a bucket, right? Okay. So how do I get my margin of error here? Yeah, you just do the subtraction. That's your margin of errors between those two. So you get what? 0.043. What happens to your margin of error? It's bigger, right? At 99% confidence, my margin of error is bigger. Now, why do you think that happens? Therefore, increasing the level of confidence increases the margin of error. Why do you think that is? So check it out. If I am 99% confident, so I'm almost completely confident, right? I am 99% confident that my population parameter, right? My information about the population, my parameter is within this interval, then I'm going to have to widen that out because I have to be 99% confident. If I'm not quite as confident, but pretty good, then I can narrow this down a little bit tighter. Because I'm only 95% confidence. I'm giving myself that 5% of, could not be in there, right? Here, I'm saying 99% confident. Ooh, I got a nice big interval because I am almost guaranteeing that whatever my parameter is will be in this interval. So the more confident you are, the bigger your interval is going to be, which means your margin of error is bigger. And that's how I know I can be more confident that my actual parameter is going to fit in there, right? And by that same rationale, let's say I just only want to be 80% confident. What do you think is going to happen to the interval? Yeah, it's going to get even smaller. My margin of error is going to go down even farther, and it's going to be even smaller of a margin of error because I don't have to be as confident. It's a much smaller interval because I'm not as confident that it's going to be in there. Does that make sense? So we're using that common sense in order to pull off some of that kind of stuff too.